Arinas equation. The quantitative relationship or the quantitative dependence of temperature on rate of reaction can be explained by using Arinas equation. The Arinas equation can be written as K is equal to A e raised to minus EA upon RT. This is the Arinas equation where K is velocity constant, A is frequency factor, or we can also call it as probability constant. E stands for activation energy, R is the gas constant, T is absolute temperature. Absolute temperature means it is in Kelvin. Now, let us derive this simplified form of Arinas equation. Let this be equation number 1. Taking log on both sides of equation 1. We can write this ln K is equal to ln A. Now if we take the log of this quantity minus EA upon RT. Let K1 be the velocity constant at temperature T1 and K2 be the velocity constant at temperature T2. Then this equation, the above equation, can be written as now using these two conditions, I can write this equation as ln K1 is equal to ln A minus EA upon RT1. Let this be equation number, I am putting this as equation number 2. Let this be equation number 3. ln K2 is equal to ln A minus EA upon RT2. Equation number 4. Subtracting equation 3 from equation 4. ln K2 minus ln K1, subtract left hand side and as well as right hand side, is equal to, first I will take this ln A minus EA upon RT2. Now I will subtract this ln A, minus and minus will become plus EA upon RT1. Now this quantity, positive and negative quantity, gets cancelled. ln K2 upon K1 can be written as ln K2 upon K1 is equal to minus EA upon RT2 and plus EA upon RT1. I will shuffle this. EA upon RT1 minus EA upon RT2. Can you see this common quantity E upon R? Ln K2 by K1 is equal to, I am going to take this outside, 1 upon T1 minus 1 upon T2. Now, this is log of integration. Let us convert this log of integration into natural log. So, how we will convert this? Multiplying this by 2.303. So, 2.303. Now, this log of integration gets converted into natural log. K2 upon K1 is equal to EA upon R, 1 upon T1 minus 1 upon T2. Take this on the other side. Therefore, log K2 upon K1 is equal to EA upon 2.303 R, 1 upon T1 minus 1 upon T2. This equation is being used for solving numerical. You have to remember this equation. Now, let us test the validity of this equation. Whether Arinas equation is right or wrong. For testing the validity of equation, let us consider the general form of this equation and plot a graph. If we get a linear graph, that means it is valid. So let us prove the validity of Arinas equation. Proving validity of Arinas equation. Consider the general reaction. Ln K is equal to ln A minus EA upon R. On rearranging, rearrange this. Ln K is equal to minus EA upon R plus ln A. This equation resembles with the equation of straight line. Y is equal to mx plus c. It resembles the equation of straight line. Plotting the graph of ln K against 1 by t. If a straight line is obtained, means Arinas equation is valid. Let us see. I am plotting a graph of ln K upon 1 upon t. When I plot this graph, I get this kind of graph where intercept is ln A and slope is equal to minus EA upon R. Now note down these assignment questions. First one, how temperature and catalyst affects the rate of reaction. Number 2, write a note on collision theory. Number 3, define threshold energy. Fourth, define activation energy. Fifth, write an expression of Arinas equation and prove its validity.